Hello, I'm Paul Boer. I'm going to speak briefly about a user-specified truss heel height. This feature was recently added to Improv. First, we'll talk about the standard truss that has been in Improv since its inception. Here we have a typical triangular truss. It has a top chord, a bottom chord, and webs. Notice how the bottom chord is cut to match the top chord slope. This enables efficient joining of the top and bottom chords. This joint between the top and bottom chords is called the truss heel. Let's take a closer look at this important joint. Again, the heel of the standard truss is where the top and bottom chords join. The heel is also the bearing location. Standard heel height is a function of top chord size and roof slope. Standard bottom chord butt cut is equal to 1/4 of an inch. The vertical distance from bearing to top of truss at the outside face of the bearing is called heel height. Increasing the bottom chord butt cut makes the heel deeper. The top and bottom chords can actually separate if a large enough heel height is specified. Special detailing and design methods must be used when this occurs. Here we see a building with a standard truss. Air moves into the attic from the vented eave and out the vented ridge. Adding 12 inches of insulation to this attic creates some issues. The ventilation path is blocked if we try to fully insulate all the way to the sidewall. Attic ventilation is typically maintained by reducing the thickness of insulation at the building eave. The resulting airflow is constricted by the narrow openings. The constriction causes higher air velocity, which can cause the cold air to penetrate into the porous insulation. This is called wind washing. Wind washing can cause porous insulation to be virtually ineffective. Cold spots, condensation, and mold can result. A bit more attic space at the sidewall is needed. A 16-inch heel allows full depth insulation all the way to the sidewall. Enough room is available above the insulation to allow the air to move slowly. Wind washing is eliminated by using an insulation stop that protects the insulation in the area of high velocity. Deep-heel trusses typically cost about 10% more than trusses with standard heels. This does vary widely, however. The deep heel also increases eave height, requiring more wall steel. How deep of a truss heel is required? Insulation depth plus 2 inches will provide good results in most cases. Very high or very low slopes and vaulted ceilings can impact heel height requirements. Insulation depth can be calculated by dividing the desired attic R value by the insulating value of the insulation you have selected. Some common attic insulation R values per inch are shown in this table. Loose fiberglass, 2.5, loose cellulose, 3.5, and dense packed cellulose, 4.0. So if we need an R50 ceiling insulation and we choose to use loose cellulose, we divide 50 by 3.5 and come up with 14.3 inches of insulation required. Round up to 15 inches, add 2 inches for the heel, and we get to 17 inches, and we may as well specify 18 just to be safe. 20 inches of loose fill fiberglass is required if we chose an R50 with loose fill fiberglass. And in Improv, the maximum heel height is 20 inches, so the 22 inches required for loose fill insulation would require a custom quote. Again, 20 inches is the deepest heel Improv supports. This allows 18 inches of insulation. If we choose dense packed cellulose, this results in an R72, which is a super insulated attic. You can keep in mind that dense packed cellulose must weigh a minimum of 3.6 pounds per cubic foot. 18 inches will weigh a minimum of 5.4 pounds per square foot, or probably in the neighborhood of 6 pounds per square foot for design. I mention this because Improv does not use 6 pounds per square foot as its typical design value for ceiling insulation. How do we order or how do we specify a deep heel truss? Go to the General Building Info dialog, select the Slope Overhang tab, select Custom Energy Heel in the truss configuration form, and then you can enter the heel height that you desire. The user-specified heel height was added to Improv in January of 2017. The user can specify heels with heights varying from 6 to 20 inches. This will allow you to match existing buildings as well as provide energy heels as needed. Improv will use the specified heel height when designing the truss and detailing the building. This will provide you an accurate price and properly proportioned drawings. Any questions?